Now we're going to look at the ranges portion of the chart. Remember, X bar and R, two charts in one. The top chart shows the averages. The bottom chart, which sits right below it, shows the ranges. I've got the same data set I've had before, all right? And what I need to do is I need to calculate, as we talked about before, I need to calculate all of the R values, all right? And the R value calculation is nothing more than the high value minus the low value of the data set. And as we said before in the last video, in this case it would simply be the 922 minus the 920, giving us a difference of 0.02. These are my these are my R values, and I calculate an R value for each and every data set or subgroup. Now, the R bar, the average of the R's, which again is the average of these, it's simply the average of those. And the equation is, as you would expect, the R bar is equal to the sum of R sub j, where j goes from 1 to k. Remember, the book uses m. So in this case, what I'm doing is k is 4, or excuse me, 5, because I got 5 subgroups. So k is 5 here. So all I'm doing is I'm taking is R sub j subgroup from subgroup 1, subgroup 2, 3, 4, and 5, getting a total of those, or a sum of those, dividing it by 5, which is the total number of subgroups I have, and that gives me my R bar value, which, as we remember from before, was 0.003. This now takes us into the control limits for the R chart, or the ranges chart. Again, everything's right here in your book, page 286, constants. So my upper control limit for R is the D4 value times R bar. Remember, implied multiplication. If I go to my chart, what I'm doing is I'm now looking for the D4 values for a subgroup of 4. And as I recall, the value for that would be 2.282. So I'm going to multiply the D4 value, 2.282, times 0.003, and that's going to give me my upper control limit for the R value. Then, this looks a little different to you. Notice this. This says max 0, comma, D3 times R bar. The D3 value for a set of 4 is 0. So obviously, whatever it's going to be 0 times 0.003. But it may not always be 0. So what we're looking at, what this is saying is, either take a 0, take the maximum, whichever is larger. Either use a 0 or use this value. Now, why is that important? Because there's very good possibility in some situations, this right here could calculate a negative value. So in other words, what they're saying is, if I have let's say hypothetically that this part right here calculated a negative 0.001. I would use the value of 0, because 0 is larger than a negative 0.001. On the other hand, if it calculated a positive 0.001, then I would use the lower control limit of 0.001, because it is bigger than 0. That probably got a little bit confusing, but the issue is, here you have to look at that. Now you might be saying, how could there be less than 0, or how range in there? How can we have a negative value? Well, if you're looking at resistance or something of that nature, it's not at all common that some of the data that we may be watching or measuring could actually wind up with a calculation that leads this to go to a negative value. If that's the case, then we don't want to use that negative value. We simply want to use 0. If it's that it calculates above 0, then we want to use that larger than 0 value. In the R bar In the R chart, the ranges chart, again, we're looking for the same patterns. We're looking for out of control points. We're looking for normal indications of variation, runs, trends, cycles. We can actually see a problem emerging in one but not the other. That's why we look at the two. And if either one indicates a problem, then that's what we act upon.